At A level, you spent a lot of time drawing organic structures, so there's no point us really dwelling on it here, but it is worth just refreshing yourselves the type of ways that you can draw the structures and then which ways we're going to really want to do it for the rest of your chemical career, unless of course you go into teaching A level. So let's think about ethanol, our favorite little alcohol there. Its molecular formula C2H6O. That gives you absolutely no good information whatsoever about the structure of the molecule, because it's just saying what atoms are there and how many are there. Now at the other end of the scale, there's the way to draw it, the full or the displayed structure, that really has way too much information in it, because you're drawing all of these bonds here. It looks pretty for ethanol, but you start getting into much bigger molecules and it just gets really, really cluttered. So we generally want to try to draw the structures in a way that emphasizes the important bits and de-emphasizing the unimportant bits. So one obvious way to do that is to just draw attention to the functional group in there. So the functional formula there, C2H5, we don't care about that boring old carbon bit other than say what's there. But we are going to stick in the OH and emphasize that because that is the important thing there. However, there might be times in which we do want to specify what the actual structure of the boring bit is, and we can do that in one of two ways. We can do the condensed or shortened non-bond structure. So you can see here CH3CH2, we're breaking up that C2H5, still emphasizing the presence of the functional group, the OH there. Or we can do the condensed structure, and you can see that some people call this the condensed and some people call that the condensed, which is one reason we don't like talking about the condensed. But that's where here we're condensing from the full structure. So instead of worrying about the bonds to hydrogen, we just say, well, this carbon here's got 3 hydrogens on it, this one's got 2 hydrogens on it. But we do show the bonds between the carbons, and we also show the carbon atoms themselves. Again, not a bad way to draw it, but can get really tedious after a while if you've got an awful lot of carbons and hydrogens in there. So the way that we will almost always draw our structures is the skeletal structure, which has as little information as possible in there. Essentially, we don't draw hydrogens, we don't draw carbons, we only do draw the hydrogens if they're important hydrogens, like we see here for the alcohol. The end is a carbon and the turn is a carbon, and then we know that carbon likes to form 4 bonds, and so therefore there's 1 bond to this carbon, so there must be 3 hydrogens on it. This carbon has 2 bonds, so therefore there must be 2 hydrogens on it. Let's just do a few other fast examples. First of all, on this page, 2-chlorobutane. Draw it out like that. We'll talk more about the naming in a bit, but you should all done enough naming in the past to know this is butane because we got 4 carbons. It's a chloro on the carbon 2, so 2-chlorobutane there. The molecular formula of that, C4H9Cl. The functional formula, emphasizing that we got the chlorine there, and we don't really care about the C4H9, although at times we will, because there are different versions of C4H9. In order to emphasize which version this is, we can draw out that shortened formula. So no bonds, but the first carbon CH3, the second carbon is the one that has the chlorine on it, the third carbon CH2, and the fourth carbon CH3. We can emphasize that, of course, in the condensed structure with bonds. So there's the chlorine coming off the second carbon. But when we do the skeletal, we lose all the C's, all the H's, and we just have that much prettier structure there. Let's think about a bigger molecule, adrenaline, C9H13NO3. There is the structure of it, emphasizing or introducing here, although you've seen it before, the importance of sometimes showing the so-called stereochemistry around an atom, the geometry around that specific atom, how the atoms are arranged. You can see this is a tetrahedral carbon. The carbons that it's attached to are in the same plane of the paper, the oxygen's coming out at us, and that hydrogen's going away from us. You can start to see a little bit of clutter. So let's declutter it with the skeletal structure. So there it is right there. Notice the various ways in which we're drawing the carbons. This carbon here at a junction has already got 4 bonds, so it's just a carbon. This carbon right here has got 3 bonds already on it, so it must have 1 hydrogen, and that is of course the hydrogen that we know is going back because we're showing the OH coming out at you. Sometimes you'll hear the word methine. That means a carbon that's got 1 hydrogen on it. This carbon here has got 2 hydrogens on it because it's got 2 bonds. This is a methylene carbon. You'll hear that a lot more frequently. And finally, carbon-wise, this carbon here only has 1 bond on it, so it's got 3 hydrogens. That is a methyl carbon or a methyl carbon, and you'll hear that a whole bunch. And then again, just to emphasize, we don't write carbon, we don't write hydrogen unless the hydrogens are important, as shown here, bonded to oxygen or nitrogen. Very important when you're drawing structures, especially when you start to use ChemDoodle, which we will give you the license for if we haven't already done it, that you show the angles in a sensible way. And by and large, you'll find that the default angle to draw is 120 degrees. That's easy, of course, when you've got a hexagon, but notice here, this carbon, even though we know there's a hydrogen on it, when we're drawing it in 2 dimensions, we're still drawing that nice little 120 there, just because it looks prettier. And if we had a chain, you could measure those angles and they would all be 120 because that's the default that the drawing programs use. However, don't force 120 when it's inappropriate, and that will be rings, it will be carbons with 4 bonds, and it will be other geometries. So for example, here is a cyclooctane ring. You got to have those angles drawn correctly, because if you tried to put those on as 120, it would be thoroughly weird. If we got here this carbon with 4 on it, notice how we're pinching them up a little bit, condensing them up a bit. It looks a bit weird. We're not really saying that these angles are 60 degrees, but that's just traditionally the way that you would draw that in 2 dimensions. Of course, if you wanted to imply the 3-dimensionality, you'd have the wedge or the dashes going there, and then something like this triple bond here, those angles are 180. If you drew those at 120, you'd be getting lots of red ink all over the drawing that you've done it. Finally, of course, benzene. Back in A level, you drew it a different way. Here, now you're university students, you draw it with the alternating double and single bonds. You never, ever, ever draw it with the circle in the middle of the hexagon. Otherwise, you will incur Joel's wrath. So a very fast little excursion through how to draw structures. I know you'll know how to do it, and I know you'll get very good at it indeed.